Today's lesson has to do with reflection. I kind of started already just to get a little bit ahead, but I'm going to read this through the lesson here. The basic property of a reflection is a transformation that moves every point in the pre-image by flipping it across a line called a line of reflection. So you're always going to have a line in which you'll be reflecting the image. In this example, we do have a line, and this line is called line L. And you start off with A. Now you notice that A is on the line, so its reflection is going to stay there, so that's going to be A prime. Okay? That's A prime. Even though it's on the line of reflection, it's going to be A prime. Now C is so many units away from the line of reflection, which is the same distance to D. So you're going to have D. H is the same distance, equidistance to the line as K. So you have K, so it's segment DK. And later on, you're going to learn that for every point that's reflected over a line, it has to be equidistance from the mirror to the other point. So, and these have to be also perpendicular. So this is perpendicular, and from here to here, it's the same distance as from here to here. The line C to the line of reflection is the same distance from the line of reflection to D. And K to the line of reflection is the same distance from the line of reflection to H. And that goes on for angle F and G. F is the same distance from the line of reflection as the line of reflection to E, and then so on. So angle F and G is going to be reflected over the line L, so you have angle EWT. And then angle G is reflected over L, and that's going to be the same distance as T is the line. So that's why we're saying T is the reflection of G. Now, I went ahead and did this already for you. We have triangle ABC, which is the pre-image. And I did reflect over the y-axis. So, for example, A is going to be the same distance from the mirror to A prime. So in this case, we have two units. So it's going to be 2 units to the left. That's A prime. B is 1, 2, 3, 4, 5. So it's going to be 5 units towards B prime. And then C is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 units to the left of the mirror. And so here's our pre-image coordinates, 2, 4, 5, 7, 9, 3. And if you compare that to the new image or the image, you notice a pattern. When reflecting over the y-axis, the x values change to the opposite value. And later on in the lesson, we're going to see what happens when we reflect this over the x-axis. For this part of the notes, turn to page 7 in the packet. Drawing reflections. You learned that a reflection or flip is a transformation in a line called a line of reflection. We were just talking about the line of reflection. Each point of the pre-image and its corresponding point on an image in the same direction from this line. A reflection in a line is a function that maps a point to an image such that if the point is on the line, then the image and the pre-image are the same point. And that is, for example, in A, it's the same point. If the point is not on the line, then the line is perpendicular, bisecting the segment joining the 2 points. So here's this point, and here's this point, and it's perpendicular because they form a 90-degree angle, and it's the same distance from here to here, from here to here. To reflect a polygon in a line, reflect each polygon's vertices, then connect those vertices from the reflected image. Draw a line through each vertex that is perpendicular to the line K. Measure the distance from A to line K and then locate A prime in the same distance from the line K. So basically what you're doing is you want to know the distance from here to here, which is from here to here, and then from here to here is the same distance, so that's A prime. B is reflected over K, so B to this line is perpendicular. So from this line to B is the same distance. And then from C to the line, it's perpendicular, the reflected line, and then we have from this point to this point. So that's why we have C prime, B prime, and A prime. Draw reflections on the coordinate plane by using the techniques presented in example 3. Triangle JKL vertices J03, so that's 0, 3. Let me use this color. We have J, -2, -1, and let me take this off. It's causing some problems. So we have J, which is 0, 3. We have K, which is -2, -1, so that's K. And L is -6, 1. That's L. So we're going to connect the points. We want the line. We want to find the reflection over x equal -4. Okay, so I'm going to use what we learned in the first example. We know that it's going to be perpendicular to the mirror. In this case, it's x equals -4. That's the mirror. So it's 1, 2, 3, 4. 1, 2, 3, 4. So this is J prime. This is J. This is L. So it's going to be 1, 2. So it's 1, 2. So that's L prime. K is 1, 2, so it's 1, 2. So that's K prime. If I connect the points, yeah, there's my reflection. It kind of overlaps. What I'd like for you to do is try 3A and try to do 3B on your own. So I'll give you some time to do that. So V is going to stay there. That's V prime. T, it's 2 units above the y equals 3, so I'm going to go down 2. So that's T prime. S prime is 1, 2, 3, 4, 4 units above. So I'll go 4 units below. 1, 2, 3, 4. R prime is 1, 2, 3, 4. So it's 1, 2, 3, 4. So that's R prime. So here's V prime. V prime is on the line. So I'm connecting the points. And there's my reflection. Go ahead and try 3B. Okay, so I've graphed RSVT. Now the line is vertical. I know S is 2 units away from the line, so it's going to be right here. This is S prime. This is 1, 2, 3, 1, 2, 3. So this is R prime. T is 1, 2, so it's right here. So that's T prime. And V is 1, 2, 3, 1, 2, 3. So that's B prime. Yeah, it looks very awkward since we're kind of overlapping. But yeah, the 2 pictures will overlap. So that's done correctly. I know it's going to take some time practicing, but yeah, that's a correct way to graph that. Remember that this is the mirror. Right here, this is the mirror. And so remember, the reflection is over the line. It's the same distance in either direction. Something that you might want to remember when we're trying to, earlier in the notes, we came up with the understanding that the reflection of the y-axis is actually the x values are opposite in value. So you have -2, 3, 2, 3, -4, -4. This is 4, -4. So they're kind of opposite in x value. Now, when you reflect it over the x value, the y value is going to be different, or the y value is going to be opposite in value. So we have 1, -1, 3, and -3.